Stand by for the start of terminal count. 5, 4, 3, 2, 1. Mark. 10 minutes and counting.
It's 2:40, right?
Good afternoon. Hi. Welcome. And yes, of course, we have other people in the room here. Welcome. Thanks for joining us for the APEP launches from Wallops Flight Facility here in Virginia. As you may have just heard, we have just entered the terminal count. We've completed station checks with the range team, the test director, the PI, Sounding Rockets office here at Wallops in preparation for our APEP mission, the Atmospheric Perturbations around the Eclipse Path here at NASA's Wallops Flight Facility. As you know, many people across the United States from Texas to Maine will be treated to a stunning astronomical event, a total solar eclipse today. Very soon, the moon will cross in front of the sun and block the light from our star, darkening the skies for those in the path of totality. And for those of us that are not, we'll be witnessing an 81% eclipse here in the Wallops area, the Virginia area on the eastern seaboard. But that's not the only thing happening. Here in the skies over Wallops Island, Virginia, 3 sounding rockets will embark on a mission to unravel the mysteries of our upper atmosphere. And it's during the annular eclipse. This mission's led by Dr. Aurora Berjadia from Embry-Riddle Aeronautical University, who will study how the sudden reaction in sunlight during the eclipse affects our upper atmosphere, or the ionosphere. The 3 rockets are set to launch 45 minutes apart, with our first rocket set to leave our MRL launcher at 1440 or 240 Eastern time here locally. It'll be at the beginning of the eclipse. The second one at 3:20 at the peak of the eclipse, and the third and final rocket we will launch at 4:05 Eastern towards the end of the eclipse. We are at, and in just about 8 seconds, we'll be at 8 minutes and counting for our first rocket leaving the MRL launcher from Wallops Flight Facility's launch range out on Wallops Island, Virginia. Right now on your screen, you'll see the MRL launcher as the closest launcher to us, looking at the screen. To the right of it is the 50K launcher, which will be our last launcher today. So we'll be launching from the MRL, and then the ARC launcher, second, and third, our 50K launcher.
Nominal main payload. ACS track 416.
Over the course of the next couple hours, we're going to share tons of information about the experiments, as well as listening in to our range control audio and all the folks that are participating in the launch today. We'd like to welcome Dr. Berjadia, our PI here, is a principal investigator for this launch here to Wallops Island, and all the great folks that are supporting this launch today. And now we wait as we approach 6 minutes, 30 seconds from launch number 1.
DPM, M&O.
Go ahead.
Yes, sir. On the swarms, I can confirm the fixed TM has a lock on 1 through 3, no lock on 4, and readout has a lock on 1 through 4.
Copy that. RSO, ROA.
This RSO, stand by. SPLC, check 422. ROA, this is RSO, go ahead.
Provide final wind-weighted settings.
Final settings are as follows. Azimuth 100.4, elevation 79.2.
Azimuth 100.4, elevation 79.2.
Good readback.
LC, ROA.
Go for LC.
MRL launcher, final wind-weighted settings are azimuth 100.4, elevation 79.2.
LC copies and work.
And as you can hear, we just passed on the final launcher settings, azimuth and elevation. Came from our range safety officer to our ROA, range operations, and then on to launch control, who will make the settings at the launcher you see on the screen out at the launch pad on Wallops Island. This, of course, goes through safety scrutiny review to make sure that we avoid any hazards and remain within the hazard area dictated by our range safety officer. We are now at 4 minutes and counting.
Copy that. Check 425.
And if you're just joining us, we just passed 3 minutes and counting for our first rocket launch today from Wallops Island, Virginia, as part of the Atmospheric Perturbations around the Eclipse Path, or APEP mission. Much easier to say APEP. I'll say that from here forward. APEP launch here from the MRL launcher on Wallops Island Range. We will have 3 rocket launches today. MRL will be our first launcher, which is the closest to you, looking our left on the left of the screen. The ARC will be our second launcher, which is not on screen currently. And then our third launch will be from our 50K launcher, which is currently on the right of screen that we're seeing now. Again, the APEP mission here during the eclipse to study disturbances in the ionosphere with our PI, Dr. Aro Perjadia, here from Embry-Riddle. We also have other co-PIs in this mission that we'll talk about after this first launch. We are now at 2 minutes and counting. Mark.
PTM check 434.
PLC check 435.
Actual launcher settings are azimuth 100.4, elevation 79.2.
Copy that. LC, check 436.
ACS check 437.
Experiment, you go.
Experiment go.
PLC,
PLC go.
PTM,
Go.
STM,
Go.
ACS,
Go.
PI,
Go.
SRPO,
Go.
check 438, 439.
1 minute.
SPLC check 441 go.
-50 seconds. -40. -30.
Arm verified. Check item 445.
-20, 19, 18, 17, 16,
ACS check 447
15,
go.
14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Mark T0.
And our first APEP rocket has
Plus
left
10.
the rail. Let's
Radar
listen in.
tracking. Fixed TM
Mission
readout
squib.
locked.
Motor pressure.
Plus
All
20.
TM antennas tracking.
Plus 30.
Here's now a look inside our RCC. That's the range team,
Plus 40.
as well as sounding rockets. Our PI, Dr. Brajati, is also in the room. All now observing the data on the screens in front of
Plus
them.
50.
As we have launched
Squib.
1
our
minute.
first rocket
Separation
of a
squib
3-rocket
and break
salvo
wire.
today from Wallops Island as part of the APEP mission.
ACS-1.
Swarm
ACS
door
on
squib.
target.
Eject squib. Got all plunger switches and brake wires. Aft skirt squib.
Skid lock on all 4 swarm. All are transmitting at high power. ACS-2 on target.
Boom squib. Looks like all 4 booms extended. Looks like the 0-degree boom did not deploy.
Okay, we've passed 2 minutes, 40 seconds in flight for our first launch from the MRL launcher here at Wallops Flight Facility in support of the APEP launches. So thanks for joining us. Good afternoon. Just some information, some background on the 3-rocket salvo we'll be doing here today. Each rocket will deploy, you'll hear some of the chatter on the range networks. Each rocket is planning to deploy sub-payloads about the size of a 2-liter bottle of soda. Each rocket essentially creates 5 suborbital profiles, providing 15 different data sets from just 3 rockets. So that's all the data we're going to get from 3 launches today here at Wallops. The atmospheric and ionospheric perturbations can happen at any time and place, but why we like the eclipse, or why scientists like the eclipse, not including myself in that group of folks, most science campaigns have a 2 to 3 week window. With eclipses, they know exactly when this dynamic is going to happen, allowing science teams to craft an easy and comprehensive experiment to study the basic physics that would take them weeks, as said before. Again, this is the APEP mission.
So this is LPM. Are we clear to go outside just to check for any gross hazards?
So we're listening now to the LPM request permission.
Yeah, you're clear.
Go out to the pad
Copy that.
from the test director. Just going to check around, make sure there's no hazards, obvious hazards around the pad, safe the pad, and then we'll get ready to move on to our next rocket from our ARC launcher, which will be not on camera yet. They'll swing cameras around for a good view of that launch. And that one is slated for a 15:20 p.m. here on the Eastern time for rocket number 2. Right now, we're going to share a video, the Eclipse Explainer video, so enjoy.
On April 8th, 2024, portions of the United States will get to enjoy the sight of a total solar eclipse. The last time this took place was back in August of 2017. So this is a good time to refresh our memory as to what's going to happen, why it occurs, and let you know where you can watch the show in the sky. A solar eclipse occurs when the moon moves between the Earth and the sun, blocks the sun's light, and casts a shadow on the Earth. When the moon completely covers the bright disk of the sun, that's a total solar eclipse. This differs from a lunar eclipse, where the moon moves behind the Earth, so it's now the Earth blocking the sun's light on the moon, creating a shadow on it with a red tint. To remember the difference, just remember what object gets darker. With a solar eclipse, it's the sun, and during a lunar eclipse, it's the moon. Because the moon's shadow is relatively small, a total solar eclipse is a pretty rare event to see. In order to do so, you have to be on the sunny side of the planet and within the path of the moon's shadow. And that path is affected by the Earth's rotation, moon's orbit, and where they are in their orbit around the sun. There are a lot of moving parts that go into creating this incredible sight. And speaking of parts, during a solar eclipse, the moon is actually casting a shadow consisting of two parts, the umbra and penumbra. The moon's umbra is the part of the moon's shadow where the entire sun is blocked by the moon. In space, it's a cone extending about 232,000 miles behind the moon. It's when the small end of this cone hits the Earth that a total solar eclipse can be seen. Those factors are why only a limited number of locations on Earth get to actually see it. So, if you find your area in the path of totality this year, treasure the sight, because on average, that same spot on Earth won't see another total solar eclipse for 375 years. The area around Carbondale, Illinois, however, has hit the cosmic jackpot, getting to experience this year's eclipse, as well as the one from 2017. But their next view of a total solar eclipse won't happen until the year 2343. When you check out an eclipse map that depicts the path of totality, keep this in mind. While many maps will show a circle representing the moon's shadow, the true shape of the umbra is more like an irregular polygon with slightly curved edges. This is due to the fact that the moon isn't a smooth sphere. It has mountains, valleys, and craters on its surface, all of which affect the passing sunlight and shape of the resulting shadow. NASA's Lunar Reconnaissance Orbiter spacecraft, which has been orbiting the moon since 2009, has provided scientists with incredibly detailed photographs, terrain maps, and other sets of data that have allowed us to better understand the shape of the moon's surface. This, in turn, has given us the ability to create more finely detailed maps depicting which specific areas on Earth lie within a solar eclipse's path of totality. Regions outside the narrow path, depending on their distance from it, will get to witness a partial eclipse to varying degrees. As you can see, the penumbra shadow passes over almost all of North and Central America, as well as Greenland, Iceland, and the Western British Isles. This 2024 total solar eclipse is therefore giving millions of people the opportunity to share in this rare and dynamic interaction between our Earth, Sun, and Moon.
Thanks, Jamie, for that video. I didn't have to say penumbral or autumnal and explain the shadows there. That was very good. I enjoyed that video. Education. Welcome back. We are here at Wallops Flight Facility in support of the APEP mission from NASA Wallops Flight Facility in Virginia. During this mission, we're going to launch 3 identical sounding rockets. We've already launched 1. This is going to study how the sudden drop in sunlight affects our upper atmosphere. The mission, known as Atmospheric Perturbations around the Eclipse Path, or APEP, is led by our PI, Dr. Raro Berjadia. He's a professor of engineering physics at Embry-Riddle Aeronautical University in Daytona Beach, Florida, and his research team is no stranger to Wallops. They've had mission launch from this site as recently as August of 2022. That mission was named SPEED, also an acronym, Speed Demon, tested technology that will be used on today's mission. So not only the team is no stranger to launching at Wallops, the payload that's being launched today has already successfully flown on a Wallops rocket. The same set of experiments were launched during the annular eclipse on October 14th in 2023 from the White Sands Missile Range in New Mexico. APEP is designed to measure changes in the ionosphere during the solar eclipses using instruments such as Langmuir probes, electric field probes, magnetometers, ionization gauges, and accelerometers. Simultaneous multi-point measurements will be achieved by ejecting 4 instrumented deployables from each payload or swarm. Springs are used to deploy the ejectables at a velocity of 3 meters per second, and they will take data for about 7 to 8 minutes. This allows taking measurements in a larger volume of space. So in the T plus, or in the T plus count, you heard a lot of chatter going on about ejecting things from the vehicle.
Yeah, when you
that's what that was discussing.
Let's listen in now to the next T0 is. I can put it out to our external partners.
Copy. Stand by.
And you heard the TD asking for our next targeted T0, which we have as 3:20 p.m. here local on the East Coast, 1840 Zulu or GMT. For those listening outside of the Eastern Seaboard, we now have our camera zoomed in on the ARC launcher, which will be the next launcher for the next rocket launch here.
On all assets.
TD is SRPO.
Go for TD.
We're targeting the nominal T0 for the second one of 1520.
M&O DPM.
M&O.
Copy 1520.
So as you just heard, we're sticking with the originally targeted 1520 or 3:20 p.m. Eastern Time T0 for the second rocket in the APEP mission. Let's listen in to range control.
Go for TD.
I will let the B clock roll and then fire the next vehicle on the A clock if that's okay.
For me.
DPM, M&O.
Go ahead.
Yes, ma'am. Recorders are stopped.
Thank you, sir. Check 453.
MM, this is PM.
ROA RSO.
Go ahead.
Vehicle performed nominally. Check item 454.
Copy that.
And PM and SRPO, I'm going to go ahead and put the clock at T-minus 15 without objection.
SRPO concurs.
PM concurs. I just want to keep the B clock rolling for safety reasons.
Copy. Programmer, A clock at T-minus 15 minutes and holding, please.
Roger, 15 and holding.
And LPM, do you need to align cameras again?
That's affirmed. We'll send them out now.
All right. Got our avoidance?
RC, ROA.
Not necessary.
RC, go ahead.
It's not necessary. You don't need it. LPM TD, you don't need ARF avoidance?
That's affirmed. We do not need RF avoidance.
Copy.
As you can see, we're taking a peek back into the RCC now, Range Control Center. As we've reset the clock to 15 minutes and holding, so they'll pick that up when we get closer to the terminal count for our second rocket launch today from Wallops Flight Facility, targeting a 3:20 local departure from the rail. We're about, let's call it 27 minutes away from our second launch. Just an overview of the rockets being used today. The vehicles for this scientific endeavor are Black Brant 9s, which are specifically designed for high-altitude research. These rockets will soar to altitudes of up to 350 kilometers or 270 miles each, standing at an impressive 53 feet. Let's listen in now for a science update we have coming across the RCC feed.
And programmer TD.
This programmer, go ahead.
Why don't you just set us up for a 1920 T0?
Roger, can do.
As you can see there at the bottom of the screen, our PI, Dr. Verjadia, conferring with his science team. We're waiting now for a science update. Closely listening to the range feed to see if we have satisfaction on deployment of these sub-payloads from the first rocket that launched from Wallops just 24 minutes ago. Let's listen in.
Test 1, 2, 3, 4, 5.
While we wait for our PI and some science updates, back to the rockets. The Black Brant 9s are a two-stage rocket, which means they have two separate engines that fire in sequence to reach higher altitudes. That first stage is powered by a Terrier motor and will thrust the rocket, while the second stage uses a Black Brant motor. Both motors are powered by solid fuel, which will burn quickly, meaning this will be a very fast rocket. So as you saw from our first launch today, if you look away, you're going to miss it coming off the rail. Make sure we pay attention. It doesn't climb much like the Antares rockets that launch here to resupply the ISS. The sounding rockets are typically used to gather information about a specific phenomena or to test new technologies or instruments in a space-like environment. As we said earlier, we're getting right to the edge of space in the ionosphere today with these rockets, and they are fast off the rail. Check back in with the range feed. Continuing more information about these sounding rockets. As we said, we get right to the edge of space, a space-like environment with a sounding rocket. They're not designed to reach orbit or stay in space for an extended period of time. They're designed to reach suborbital altitudes, typically between 50 and 1,500 kilometers above the Earth's surface before returning to the ground. Today's rockets are expected to reach a maximum altitude of 340 kilometers. These rockets are provided and built and integrated with the payloads on board as part of NASA's Sounding Rockets program, coordinated by the Sounding Rockets Program Office, or SRPO, located right here, NASA's Goddard Space Flight Center's Wallops Flight Facility. The Sounding Rocket Program Office plays a crucial role in providing suborbital launch vehicles, payload development, and field operations support for NASA and other government agencies across the globe, not just here at Wallops. They work hand in hand with the Sounding Rocket user community, offering launch opportunities that span a wide range of science applications. The partnership with SRPO enables these rocket launches to contribute to NASA's strategic vision and goals in earth science, heliophysics, and astrophysics. The annual suborbital missions, approximately 20 of them, not only provide researchers with unparalleled opportunities for scientific research, but also allow the testing and development of new instrument and sensor concepts. These rockets are, of course, more than just instruments of research. They are a training ground for the next generation of space scientists. The short mission life cycle, coupled with hands-on instrument design and integration, ensures that future scientists receive the training and experience necessary for NASA's larger, more complex space science missions. It's a platform that stimulates innovation, technology, maturation, and rapid responses to scientific events. And it looks like our camera is back on our next launcher. All right. Yeah, we're ready for our next launcher. which will be the ARC. And we're still targeting that 1920 Zulu or GMT time, which will be a 3:20 local here on the East Coast for our second rocket in the APEP launch campaign, a 3-rocket salvo launching today from NASA's Wallops Flight Facility.
Go ahead.
All right, so we looked at the main payload data so far. It looks like all the booms did deploy, and the data does look pretty good. There are some squibbles on the accelerometer on the main payload that we seem to be seeing. We'll have to look more into that as to what that sporadic squibbles on the accelerometer are. We are still looking at the data of the ejectables, but it looks like all of them came out. And at first look, the coning looked smaller, which is very good. Yeah, and you know, as such, all the main payload instruments work great. Signals looked better than what we had seen during VSMR. So all that's good, and I'll keep you posted as we analyze the sub-payload data more. Over.
So we just heard from our PI, Dr. Arop Rajadia, and his science update. It all sounds optimistic. Good data set coming in from our first launch of 3 here at Wallops Flight Facility. We've had some questions come online we wanted to address. Can I see the rocket contrails with my Eclipse glasses on? So no, you won't be able to see the rocket's contrail in the sky with your Eclipse glasses on. As long as you aren't looking directly at the sun, you can remove your glasses and look at the rocket and the rocket contrail. Again, do not look directly in the sun. This day or any day, but especially today, right? We don't look directly in the sun. I had to tell my mother that today via text. She asked me, if I wear my glasses, can I look at the sun? And I said, did you get Eclipse glasses? She goes, no, my prescription glasses. No, Mom, please don't wear those. Wear Eclipse glasses. We now have a video we're going to share with you on how to safely observe a solar eclipse.
For many people, viewing a total solar eclipse in person is a once-in-a-lifetime opportunity. But whether you're a first-time viewer or an avid eclipse chaser, solar eclipse safety is essential. It may be tempting to gaze directly at the sun or to use your regular sunglasses during these celestial events. Don't. Regular sunglasses aren't good enough. You need proper, solar-safe viewing glasses or an indirect viewing method whenever the bright face of the sun is visible. The only time you can look at a total solar eclipse without eye protection is during the brief period of totality when the moon completely covers the sun. Viewing any part of the sun's bright disk without protection, even for a short amount of time, could cause serious eye damage. One of the most common methods used to view a solar eclipse is with solar viewing glasses, also known as eclipse glasses. Eclipse glasses are specifically made to protect your eyes from the sun's intense rays and are different from ordinary sunglasses. Before using any eclipse or solar viewing glasses, check that they are ISO certified. If your eclipse glasses appear scratched or damaged, do not use them as this could result in serious eye injury. Another easy way to safely view a solar eclipse is with pinhole projection. This is useful if you don't have access to eclipse glasses or other safe solar filters and offers an easy way to quickly view the magic of the eclipse. There are several techniques you can choose from for this viewing method. The simplest is to use your hands. With your back to the sun, cross one hand over the other with outstretched fingers to create a waffle pattern. Look at your hand's shadow on the ground. The little spaces between your fingers will project a grid of small images of the sun, showing the sun's crescent shape during the eclipse. You can also see a similar effect as the sun shines through holes formed between tree leaves. The tiny spaces between the leaves act as pinhole projectors, scattering images of the sun on the ground. Anything with small holes like a hole-punched index card or even a colander from your kitchen will work too. If you're feeling crafty, you can build a box pinhole viewer. Using everyday household items, this method streams sunlight through a pin-sized hole to project an image of the sun onto a white sheet of paper taped inside the box. The longer the box, the bigger your image of the sun will be. For an even bigger image, you can use optical projection. This viewing method uses a telescope or binoculars affixed with a solar filter to project the image of the sun onto a large viewing surface. This method creates a bigger, brighter, and sharper image that many people can view at the same time. However, you should not attempt optical projection unless you are an experienced astronomer and can supervise your equipment at all times. Want a closer look? When using a telescope, binoculars, or other optical device, you must first install a certified solar filter to the front of your instrument. Eclipse glasses can't be used with these devices. The certified solar filters block most of the sunlight before it enters the device, safely giving the operator a front row seat to see the eclipse in even more detail. Experiencing a solar eclipse is one way everyone can participate in NASA science. Now you have the knowledge to participate safely. Happy eclipse viewing!
Observing our eclipse today. I'm sorry. Great video. Thank you. Thank you to my assistant. Another great video to explain some safety, as we addressed earlier. If you're looking to see the rockets in flight, the contrails in flight, obviously, if you're looking away from the sun, you can remove your glasses and look for the rockets and observe the contrails in the sky. Do not look directly at the sun, even though it's obscured. It's still very powerful, if not more. So, and it will do damage to your eyes. So do not remove your glasses looking directly into the sun, but away from them, you can try to catch the rockets and their contrails in flight. On camera now is our next launcher, the ARC from Wallops Flight Facility. We have launched one. Welcome back. We've launched one of 3 rockets as part of a 3-rocket salvo today from Wallops Flight Facility. We just passed 13 minutes, 13 minutes and counting for our second rocket launch as part of the APEP mission, or Atmospheric Perturbations around the Eclipse Path. Today, of course, many people across the United States here in North America, from Texas to Maine, will be treated to a stunning astronomical event, a total solar eclipse. The moon will cross in front of the sun, block the light from our star, darkening the skies for those in the path of totality, and many people outside the path will see a partial eclipse. We here in the Virginia Wallops region are going to get about an 81% totality around peak totality time, which is 1530-ish, 330? 322 will be the most we'll see at 81% here in the Wallops region. This mission is led by Dr. Aurore Barjadia from Embry-Riddle Aeronautical University, and they're aiming to study how the sudden reduction in sunlight during the eclipse affects our upper atmosphere or ionosphere. We just passed 12 minutes and counting for our second launch in the APEP mission. You can see the ARC launcher here. We've done station checks are complete. We're awaiting final launcher settings that we'll get. The ROA will request from the RSO, and after the RSO safety analysis, they will pass on the final settings. ROA will then pass those to LC, you'll hear as an acronym for launch control, out at the pad, and they will adjust the rail with the vehicle on board, and we will be set to go for the second launch and our 3-rocket salvo as part of the APEP mission from Wallops Flight Facility today during the total solar eclipse.
Termed okay. In 5, 4, 3, 2, 1, mark. 10 minutes and counting.
ACS check 473, 474.
TDRSO, this is PM on channel 1. PI wants to hold at T-minus 3 minutes. Do you copy?
Copy. Do you have an idea for how long he's going to want to hold? Because I might need to get some more balloons up in the air.
PLC check 470.
The intent is to hold for not more than 5 minutes. Would you need another balloon?
So no more than 5 minutes hold? Is that my understanding?
We're going to hold at 3 minutes for no more than 5 minutes and pick it up.
Copy. I think we'll be okay.
Copy. Programmer, when we get to 3 minutes, if you would hold.
Yes, programmer.
PLC check 471 and 472.
Programmer, it's Chidi. We're going to hold at T-minus 3 minutes.
Roger, copy. Hold at 3.
We're going to pick it up no later than 5 minutes from that.
Roger, I'll await your word, sir.
RC DPM.
This is RC, go.
Request interrogation of transponder.
In work.
Check 475. MNO DPM.
MNO.
Record RF parameters and report TM lock.
Okay, as we just heard, the PI has requested a hold at T-minus 3 minutes. We're passing 8 minutes now and counting. Once we get to 3 minutes, we're going to hold no longer than 5 minutes. Our assumption is the PI is waiting on something he wants to see in the science realm. So we'll wait. That would put us to 322, and then plus the 3 we're holding would be a new T0 around 325 local here, Eastern time. Or earlier, right? They could pick it up. So we've got the live feed on. We will hear 5 minutes would have been the max. So max T0, the latest would be 325. It could be earlier. But we're all listening in with wanting ears as we approach totality here at 322 local in the Wallops, Virginia area. And we will hold at T-minus 3 minutes. We are coming up on 7 minutes now and counting. We will hold for no longer than 5 minutes. Let's listen back to range control. There'll be a lot of chatter here now as we are in the terminal count, and all folks are providing inputs.
MNO DPM.
MNO.
Confirm good lock on swarms.
Stand by.
STM check 485.
DPM, MNO, I can confirm the readout has a lock on all 4 swarms. Fixed TM has a lock on 1 through 3 swarms.
EXP check 486, good swarm data.
Copy MNO check 484.
SPLC check 487.
RSO, ROA.
This is RSO. Go ahead.
Provide final wind-weighted settings for ARC.
Final wind-weighted settings are as follows. Azimuth 100.9, elevation 79.3.
Azimuth 100.9, elevation 79.3.
Good readback.
As we just heard, we got our final wind-weighted settings for our launcher from the RSO to the ROA. She will pass that on to the launch control out on the island, and they will set the launcher. We're passing T-minus 5 minutes now, expecting a hold around 3 minutes. Just some of information on the payload. As we talked about earlier, to capture a wide variety of data, these rockets are using technology that was developed and proven right here at NASA's Wallops Flight Facility. The swarm communications technology will release 4 sub-payloads that are carrying scientific instruments that will measure changes in electric and magnetic fields, density, and of course temperature. The swarm canisters act like additional rockets with their own telemetry and scientific instruments, and each rocket will carry 4 swarm canisters which you can picture as a similar size and shape as a metal coffee thermos or a 2-liter bottle of soda. By ejecting multiple sub-payloads away from the main payload, the science team can collect additional valuable data. Each canister streams its unique telemetry and science data using onboard radios through the host rocket's communications system to the ground. Each rocket is carrying an identical set of 4 sub-payloads in the form of swarm capsules. 3 of the swarm capsules contain instruments built by a team from Embry-Riddle, and the 4th swarm capsule was built by researchers from Dartmouth College up in New Hampshire. Swarm is not an acronym. One of the challenges when designing a rocket payload is making sure it's properly protected during launch. When rockets experience extreme heat, pressure, and vibrations during the launch, so payloads must be designed to withstand these conditions and the rigor they are about to be put through. The payload skin that contains the scientific instruments for this rocket was designed, built, and tested by the Sounding Rockets Program Office right here at NASA's Wallops Flight Facility in Virginia. We are at 3 minutes, 35 seconds and counting, expecting a hold at 3 minutes, which would be no longer than 5 minutes. So our latest T0 would be 3:25 local, 1925 GMT or Zulu time. We're coming up now on 3 minutes, 15 seconds, and we'll expect the hold. Let's listen into range audio.
Three minutes and holding.
PI, this is SRPO.
Go ahead, SRPO.
Let us know when you want to pick up the count.
Sounds like a plan.
So it's best if we don't just try to pick it up right away. If we can announce a time that says this is the time we're going to start if we can.
Current plan still is to pick up the count at 3:22, which would be the 5-minute hold from 17 to 20. That's the current plan.
TD, the planned new T0 is 1525. Do you copy?
1525.
Programmer copies as well, TD.
RSO, do you copy?
So as we just heard, SRPO polled the PI, who is our principal investigator, that's Dr. Brajadia, and he wishes to go to the end of the window, 5 minutes as the maximum hold they had indicated earlier. So we will go to that, putting our new T0 at 3:25 p.m. local and 1925 GMT or Zulu time. I want to take this chance to talk about some of the teams that are involved in this launch salvo here from Wallops. Instruments on board the rocket were built by students and faculty members from Embry-Riddle, Dartmouth College in New Hampshire as well. A host of ground-based observations are going on throughout the nation today, and they're also going to support this mission. Co-investigators from the Massachusetts Institute of Technologies, Haystack Observatory in Westford, Massachusetts, will run their radar to measure ionospheric perturbations farther away from the Eclipse Path. And as well, a team of students from Embry-Riddle down in Florida will deploy high-altitude balloons reaching 100,000 feet every 20 minutes to measure weather changes as the eclipse passes by. All of these measurements will aid ionosphere modeling efforts led by scientists at the University of Colorado Boulder and Embry-Riddle. Those are the teams involved in the science portion here. Of course, we spoke about our SRPO, our Sounding Rockets Program Office here at Wallops. We also have Wallops range personnel involved, from project managers to test directors, launch pad managers, OCOM team, all the folks involved. Range safety, we have range safety officers. We have surveillance of hazard areas, a whole department within the range surveils offshore and in the general vicinity. To make sure that we keep the public, aviation, and our mariners safe from anything we're doing with regards to the launch. Again, our cameras are fixed back on our next launcher, the ARC launcher, which is a rail launcher. We do have our final settings. We're still at 3 minutes, and holding, and about, call it 5 minutes from T0 once we pick up the count. 1525 is confirmed for our next T0. So let's listen in at range control.
Stations, if you're looking at the monitor straight ahead of us, looks like we got individuals that are on the hook that shouldn't be. RSO is looking at it to determine whether we're green or red at this time.
Three minutes.
Hey, Jordan, can you zoom in? We can see how many people are in there.
Zoom in on which camera?
FLIR.
Stand by.
Go ahead.
Is SRPO. Are you guys picking up?
Yep. PLC check 491.
So we need to know whether you're going to hold us or not.
I think we're okay, TD. Just we're given a baseline number of people we see, getting an E sub C value, and making sure we're below our fixed values.
Copy.
PLC check 492.
ACS check 493.
M&O, DPM.
M&O.
Report TM lock and verify no change in TM signal strength.
Standby.
RC, DPM.
RC, go.
TDR, so we are within values.
PTM check 499.
RC, confirm no change.
PLC check 497, 498.
No change in transponder.
500.
DPM M&O, report TM lock and verify no change.
LC ACS, do you have final launcher settings?
Yes, I was waiting
Check
for the net to calm down.
494,
Actual launcher settings are as 100.9, elevation 79.3.
Copy, LC. SPLC check 506, go. ACS check 502.
Experiment, you go.
Experiment, go.
PLC. PLC, go. PTM.
Go.
STM. Go. ACS.
Go.
PI.
Go, go, go.
SRPO.
Go.
Check 503, 504.
30.
Arming verified. Check item 510.
20.
ACS check 512, go.
Five, 4, 3, 2, 1, mark. Radars are tracking.
Ignition squib, motor pressure.
Success. And our second vehicle has left the rail of the ARC launcher here, live from Wallops Flight Facility in Virginia. As part of the APEP launches, a 3-rocket salvo that NASA Wallops Flight Facility is launching today in conjunction with Dr. Auro Berjadia from the Embry-Riddle Aeronautical University in Florida. APEP, of course, is an acronym. Atmospheric Perturbations around the Eclipse Path. We are launching 3 rockets today, 4 sub-payloads on each, for a total of 12 different data sets that will be collected today and back to the universities and academia for study in our ionosphere. Let's listen in as we're in the plus count, and we take a look in the RCC. Bottom of the screen center is our PI, Dr. Berjadia, and his science team.
Swarm squib, all plunger switches. Eject squib, all brake wires.
ACS 1 complete.
Half skirt squib and brake wire.
STM has lock on all Dallas units. All are transmitting at high power.
We had splash on the booster.
ACS 2 aligned and complete.
I show all 6 potentiometers, show booms deployed. As far as micro switches, I got all except for the 0-degree micro switch.
TD, RSO, this LPM, can we check outside for gross hazards?
So you good with that?
RSO's good with that. We're at plus 2 minutes.
We're good.
As we approach 5 minutes in flight for our second vehicle launch here from Wallops Flight Facility today as part of the APEP mission, we can go. I wanted to discuss one more time about the mission that is at hand here. We have 1 launch left of 3, known as the Atmospheric Perturbations around the Eclipse Path, or APEP, led by our PI, Dr. Auro Berjadia, a professor of engineering physics at Embry-Riddle Aeronautical University in Daytona Beach, Florida. This research team is no stranger to Wallops and had a mission launch from this site as recently as August 2022. That mission, named Speed Demon, tested technology that will be used on today's mission. Not only is the team no stranger to launching at Wallops, but the payload that's being launched today has already successfully flown from right here on a Wallops rocket, courtesy of our Sounding Rocket Program Office. The same set of experiments were launched during the annular eclipse on October 14th, 2023 from the White Sands Missile Range in New Mexico. We are now approaching 6 minutes in flight, and we'll listen into range control for an update on the next launch, which is slated for a T0 of 4:05 p.m. Eastern Time, or 16:05.
ACS-3 aligned and complete.
SRPO TD, do you have an estimated next T0?
Stand by. TD, SRPO.
Go for TD.
We're currently targeting a new nominal T0 of 1615, but the PIs continue to assess.
Copy.
When do you want to make that decision, SRPO? Do you want to push through the same way we did last time or hold earlier? TD's PM. We're going to conduct the same plan we did last time, shifting the 1615 with a hold at T-3 to get there. Do you concur?
Concurs.
RSO, do you copy?
RSO copies, 1615.
LOS for TM assets.
PTM, this is PI.
LOS, all radars.
Did you call STMPI?
I called PTM to see if he can replay us the data.
I'm setting it up now.
Excellent, thanks.
PI, PTM.
Go ahead, PTM.
Should be playing back. Let me know if you see something.
Yes, we are seeing data. What time is this? Is it before launch or at launch?
It's about 40 seconds before launch.
Okay, we are getting data.
And MNO, do we have TMLOS?
Yes, sir. I called out TML LOS at 1936.
Copy. And did we stop recorders?
Yes, sir.
Copy. Okay, programmer, set us up for 2015 T0.
Roger, set up 2015.
ROA, RSO.
Go ahead.
Vehicle performed nominally. Check item 519.
Copy that.
And SRPO, any reason to take measurements?
Negative. They can go ahead and de-elevate the ARC.
Copy. PM, you copy?
PM copies.
LCTD, the launcher is yours.
LC copies.
And RSO TD on one.
Yes, RSO, go ahead.
Do you care for a quick discussion on SC on Channel 5 about these three people?
I think that'd be a great idea. Let me change my headset better.
Okay, RSO and SC, let's go to Channel 5, please.
And welcome back, and thanks again for joining us for the broadcast of the APEP mission, 3-rocket salvo from here at Wallops Flight Facility. Camera is now zeroed in on our final launcher, the 50K launcher, which will be our final of the 3-rocket launch event today. We just passed 32 minutes and counting for the final rocket. We go over some 10 things to know about the ionosphere. I dug up from science.nasa.gov. In case you didn't know, the last total eclipse that we had visible here from North America was in 2017. And the next total solar eclipse that will be visible from North America will not happen until the year 2044. So we're going to have a while to wait for our next one. That's why our PI, Dr. Brajati, is very excited about the data set he's going to get collected from this event here at Wallops today and the launch of 3 rockets into the ionosphere. Some things about the ionosphere. It's a home to all the charged particles in the Earth's atmosphere. Earth's ionosphere overlaps the top of the atmosphere and the very beginning of space. So we're right on the edge of space as we enter into the ionosphere. The sun cooks gases there until they lose an electron or two, which creates a sea of electrically charged particles. The ionosphere is also where Earth's atmosphere meets space. It stretches roughly 50 to 400 miles above the Earth's surface, right at the edge of space. Along with the neutral upper atmosphere, the ionosphere forms the boundary between Earth's lower atmosphere, where we live and breathe, and the vacuum that is space.
MM check, 521.
We hear him checking through the countdown right now. That 521 and our total count for the 3 rockets today. Sometimes the ionosphere changes, and sometimes it's unpredictable. The ionosphere is constantly changing because it's formed when particles are ionized by the sun's energy, and the ionosphere changes from Earth's day side to night side. When the night falls, the ionosphere thins out as previously ionized particles relax and recombine back into neutral particles. That's why the eclipse is of interest to our PI, because this is all happening inside of a very short window where they can target the science with their vehicles and sub-payloads that are deployed. We just passed T-minus 30 minutes and counting for our final launch. So let's listen into range control.
That's a firm in work.
ROA, just checking. Did we already get RF avoidance?
You didn't need it the last time.
Copy.
Do you need RF avoidance for this one?
No, that's a negative. Do not need it.
Copy. TV off console for 5 minutes.
ROA LPM.
Go ahead.
Check items 523 and 524. Pad 2 is clear.
Copy that.
M&O, it's PM. Would you verify that radar is on and operational?
Confirm.
Copy. Check 525. TD, this is PM. We're a bit early, but I'd like to request your permission to move into terminal count.
I have no objections to that.
PI, PTM.
Go ahead, PTM.
That's it for the playback. Is that good?
That is good. Thank you. I'm still looking at the data. We'll report back in a minute. Okay, SRPO, PTM, giving a little update.
Go for PI.
All right, so yeah, on this one again, it looks like all the booms came out. I see where Adam says that one of the switches may not have latched up for the telescopic boom, but from our perspective, the signal looks very comparable between all the booms which did have micro switches. The up leg, the digital accelerometer and the analog accelerometer, they all still saw that periodic pulse. Not quite sure what that is, whether it is something banging around or if it's some leaking ACS gas or deadband, not quite sure. But after the apogee, that thing mostly went away. So the down leg was a lot cleaner. It was still there, but an order of magnitude smaller. Overall, the sub-payloads all look good. The D1 seemed to show very little coning, although D2 and D3 did have coning on them. So a lot more assessment to be done. But overall, yeah, all of the sub-payloads came out, and seems like all of the booms deployed. None of them got stuck. And some finer details to work out, but all in all, good.
Happy to hear that. Thanks, PI.
As we just heard from the PI himself, nominal data coming back. He seems very happy with the second vehicle. The first one was same. So we still have the third vehicle left to leave Wallops here today as part of the three-vehicle APEP mission. Our next T0 is targeted for 2050 GMT or 1615 local here. We're at about 18 and a half minutes and counting, barring any holds. As you know, on the second vehicle, we had a couple-minute hold around 3 minutes, which pushed our T0 back. But looks like we're marching on now, and until someone sees something where they would like to call a hold, we may do that again around the 3-minute mark. We had the opportunity to interview our PI, Dr. Auro Berjadia. I think you did that, right? My team member in here got to interview Dr. Berjadia. He's a professor of engineering and physics at Embry-Riddle Aeronautical University in Florida, and he explains some of the science here that he's looking for. So he was, when asked, for those who are unfamiliar, myself included, what is the ionosphere and why is it important for scientists to study this region of near-Earth space? He answered with the ionosphere is an upper layer of our atmosphere extending from about 100 kilometers to 1,000 kilometers, 60 to 600 miles roughly. And there, the pressure is low enough that charged particles can remain free and show collective behavior. This layer reflects and refracts radio signals, and it also impacts satellite communications as the signals pass through. Thus, understanding it and being able to model its dynamics is crucial to making sure that our increasingly communication-dependent and driven world has a smooth operation. So it's all good things we're looking for here today. The Eclipse gave us a targeted time and space to throw science and collect data, rather than, as mentioned earlier, a 2 to 3 week campaign. In order to collect science, this Eclipse gave us a 2 to 3 hour window where we could launch 3 vehicles and then sub payloads for a total of around 12 to 15 different data sets that they're going to take back and study to better prepare us to be able to model that ionosphere and prepare for perturbations in the future that may happen. Next, he was asked in just a few sentences explain what APEP stands for and briefly describe the overarching goal of the project. APEP is, of course, an acronym. It stands for Atmospheric Perturbations around the Eclipse Path. And as the eclipse shadow races through the atmosphere, the rapid and local sunset and sunrise create large-scale waves and small-scale perturbations that have the capability to interfere with radio communication. APEP's main goal is to study and characterize these perturbations. Again, we are currently 16 minutes and counting with no holds, with a targeted T0 for our third and final rocket today, our third and final vehicle in a 3-rocket salvo of 2050 GMT, or that's 1615 local. Did I say 2050? 2015 GMT, 1615 local time. We will launch our third and final rocket as part of the APEP mission. As we see, we will be launching from the 50K launcher.
If you're ready for them.
I'm ready.
Preliminary wind-weighted settings are as follows. Azimuth 101.0, elevation 79.0.
Azimuth 101.0, elevation 79.0.
Good readback.
Copy that. Check 532, LC, ROA.
Go for LC.
Preliminary 50K launcher wind-weighted settings are 101.0, elevation 79.0.
LC copies and work.
M&O DPM.
M&O.
PM,
Start
PD,
recorders.
SRPO.
Standby.
Go for PM.
For TD.
PI is requested that we hold at T-minus 10.
Copy. Program will hold us at 10.
Roger, hold at 10.
And as you heard, passing 13 minutes and 25 seconds and counting right now, we're going to hold
APM,
at 10 minutes.
Recorders are started.
Currently, the range working, no issues.
ROA,
This
LC.
will be our third
Go
and
ahead.
final vehicle from the 3-rocket
50K
salvo.
launcher preliminary wind weighting settings are azimuth 101.0, elevation 79.0.
Copy that. Check 533.
And that's our final input to the azimuth and elevation for the launch rail that will send our third and final vehicle into the ionosphere here today from Wallops Flight Facility. We missed the range checks again. I've been trying to get them in the range, but I was talking too much, and I was just reminded we missed range checks again, which gives us a great opportunity to see into behind the scenes here, the folks that all have a say in how this goes. Of course, our test director runs the RCC in the room, along with range safety, the PM, our PI, and surveillance. But so many folks are polled before we go into a launch. I just want to read down some of those folks. Radar coordinator, RC, M&O, mission and operations lead, the programmer, the LWO, or launch weather officer. LC is the launch control you just heard take the final settings from the ROA. LPM is our launch pad manager, part of our ground ops, our range ground ops group that's out on the Wallops Island that prepares the pad and the launchers. They're in some of those buildings and shelters you see in the live feed out on the island. Our surveillance control officer, or SCO, our range chief engineer, our main payload instruments, our payload control, NASROC payload telemetry, swarm TM, swarm payload control. our attitude control system, the NASROC mission manager, our PI, of course, SRPO. Then we end with the range with the project manager or PM, the RSO and range safety officer. And then finally our test director all have to give a go according to information that's coming in with range activity, weather, range foulers, which we're currently experiencing none of. So we have boats, surface vessels, and aircraft that we keep clear of the area via our surveillance assets. So all of those folks and that team comprises what it takes to launch these vehicles from Wallops Flight Facility. And we've done 2 today. We're going to get our 3rd, which will be quite a milestone. I know in the past we've launched HREX with a 5-rocket salvo. I don't remember the year. I was in surveillance at the time. I don't remember the year, but we did launch 5 in 5 minutes. Back in 2000 teens. We're Googling right now. We're trying to figure it out. 2012? Not quite to the teens. Okay. 2012, 5-rocket launch from right here at Wallops Flight Facility. Today, we get to experience 3 inside of a total eclipse here on the East Coast, only 81% totality. We're coming out of it now. If you're able to make it outside, we both stuck our head out and felt the change in the atmosphere. It got chilly. It got dark like it was going to rain. Yeah, the birds were chirping. It was very serene here on the eastern seaboard. It's a beautiful sight, and but it was a bit, it was different. Definitely a change, drop in temperature and sunlight. And we had our safe glasses on so we could observe the eclipse at 81% totality. So we'll stand by now as we're approaching. Here we're going to lock on 10 minutes, I think, and counting. And boom, we're there. We're 10 minutes and counting. Now, for our 3rd and final launch, we'll listen in and wait for the PI to give us his go when to pick up the count, and we'll get a new targeted T0 for you in just minutes.
TD is a PM.
Go for TD.
We're looking at a new T0 of approximately 1620, adding 5 minutes, and we'll update that as time moves on.
TD copies.
TD programmer.
Go for TD.
We're not going to be picking up at 2020, is that correct?
TD's the PM. Yes, we intend to pick up.
Want to pick it up at 2010?
No, Roger. I was looking at the wrong display.
Oh. All right.
This is SRPO to TD. We do want to go ahead and pick it up on the next even.
Roger, next even. We'll be picking it up at 2011 Zula.
So as we just heard, we're preparing to pick up the count in about 25 seconds at 4:11 p.m. Eastern Time. That would set us up for a 4:21 T0 Eastern Time from our 50K launcher, the third and final rocket in the APEP mission here from Wallops Flight Facility. As we prepare to enter the terminal count at 10 minutes, let's listen in to the range control.
DPM, please start recorders again.
DPM M&O recorders are running.
Thank you, sir. Check 531.
PLC check 535.
ACS check 538, 539.
SRPO TD, are we counting straight through?
Stand by.
RC DPM.
RC go.
Requesting interrogation of transponder.
In work.
PLC check 536. PLC check 537.
MNO DPM.
M&O.
Record RF parameters and report TM lock.
Stand by.
TD PM, we will be holding at T-minus 3 minutes for no more than 5.
PM copies.
TD copies.
DPM M&O. Our parameters recorded nominal. TM is locked.
Copy that. Check 541, 542.
RSO, this is PM.
This is RSO, go ahead.
We're going to hold at T-minus 3 for not more than 5 minutes. How's that?
Yeah, that hopefully should be no issue.
Copy, thank you.
And TD programmer copies 3 minutes hold.
And DPM RC.
Go ahead.
Beacon is trackable. Good 5, code good lock.
Thank you, sir. Check 543.
As we listen in and hear the range, check through the go, no go criteria for the launch countdown. We passed 7 minutes, 30 seconds and counting with an expected hold at T-minus 3 minutes from SRPO and the PI.
SPLC
Something
check
the PI would like to see probably science-wise. We're experiencing no weather or range Fowler phenomena currently, so we're good to go for launch. We're just going to get to a spot where Dr. Aro Rajadia, our PI, is happy with the science, and we will launch our third and final rocket today as part of NASA's Atmospheric Perturbations around the Eclipse Path, or APEP, mission
PLC check 548.
from Wallops Flight Facility here in Virginia.
ACS check 546.
Again, at 3 minutes, we will hold for no longer than 5. So let's listen in, and we'll target a new T0.
M&O, DPM, this is M&O. M&O, I can give you readout has a lock on swarms 1 through 4. Fixed TM, lock on 1 through 3.
Copy that. M&O. Check 549.
STM check 550. EXP, check 551, good swarm data.
RSO, ROA.
This is RSO, go ahead.
Provide final wind-weighted settings for 50K.
I'll stand by for after this.
SPLC, check 552.
Right. Final wind weighting settings are as follows. Azimuth 101.2, elevation 79.2.
Azimuth 101.2, elevation 79.2.
Good readback.
LC, ROA.
Go for LC.
50K launcher, final wind-weighted settings are azimuth 101.2, elevation 79.2.
LC copies and work. ROA LC.
Go ahead.
50K launcher final wind weighting settings are azimuth 101.2, elevation 79.2.
Copy that. Check 555.
Three minutes and holding.
RSO PM.
This is RSO, go ahead.
How long could we hold here with our current balloon?
Stand by. We could do maybe another 5 minutes, but if we're going to go much past that, we're going to have to do another balloon. That's going to take time to actually get that balloon up there, going, cut settings, and get you new settings. So it's hold another 5 minutes, and then it's going to take some extra time.
Copy that, RSO. Thank you. Is that 5 minutes from right now, or 5 minutes from what the plan we have right now?
That's 5 minutes from right now.
Copy. RSO, this is PM.
This is RSO, go ahead.
We're looking at picking up the count at 1625 local, which would put us at a T0 of 1628. Will your balloon still be good by then?
Stand by. So we're okay with that as the absolute maximum, but obviously you're incurring extra risk of us going out in variability. So, but anything after that, we're definitely going to have to get up another balloon. PM, did you copy?
Copy, RSO. TD, we're going to target 1628 for our T0. You copy?
Copy. You copy, programmer?
Programmer copies. Targeted T0 2028 Zulu.
All right, so we just heard a new T0 1628 now targeting. You heard a little chatter there between the PM and the RSO and the TD asking about balloons. We do launch weather balloons here that give us wind-weighted settings for our launchers. So the balloons are launched from Wallops Flight Facility, mainland and island, and we get, from that, we get at altitude wind, velocity, and direction. So the range safety officer and their team will evaluate the wind weighting settings, the data from the balloons, in order to give us good settings for the launcher settings for the rail. So that's what you heard, RSO. He didn't want too old of data. We like to keep our data fresh on what the winds are at elevation, so we know that we are providing safety to the public out there when we launch these vehicles from the launcher. So that's what you heard there in that little interchange there between RSO, PM, and TD in our efforts to get the science window, the PI wants, and remaining within safe parameters for launch. So we are now, we're still at 3 minutes in holding. When we pick it up, we're looking at a 1628 or 2028 GMT launch, which would be just over 4 minutes from now.
All stations this net, all stations this net. Stand by to pick up the count in less than 30 seconds.
All right, as we heard from PM, we're about to pick up the count in 15 seconds. We will be 3 minutes from counting. Lots of range chatter going on the net. So we will stand by. We've got a great picturesque view there off of our front porch in the Atlantic Ocean and our 50K launcher for our third and final launch as part of the APEP mission.
PLC check 556. PLC check 557.
ACS check 558.
M&O DPM.
DPM, this is the M&O. I can give you a good TM lock and verify no changes on TM signal strength.
Copy that. Check 559561. RC DPM.
RC go.
Confirm no change in transponder.
Confirm, no change.
Check 560.
PLC check 562 and 563.
Actual launcher settings are azimuth 101.2, elevation 79.2.
PTM check 564.
PLC check 565.
Copy that, LC. Check 566.
ACS check 567.
Experiment, you go. Experiment, go. PLC.
PLC go.
PTM.
Go.
STM. STM, go. ACS.
Go.
PI.
Go.
SRPO.
Go.
Check
1 minute.
568, 569.
SPLC check 571, go.
50 seconds. Minus 40. Minus 30.
Arm verified. Check item 575.
Minus 20, 19, 18, 17, 16,
check
15,
577,
14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Mark, T0.
Radars are tracking.
Plus 10.
Ignition squib and motor pressure.
Plus
Radars
20.
2 and 3 on the booster.
Plus 30. Plus 40.
Burnout.
Plus 50.
D-spin squib.
1 minute.
Sep squib and brake wire.
ACS 1 on.
Door squib and all plunger switches. Eject
one
squib,
line.
all brake wires. Skirt squib and brake wires.
Splash on the booster.
ACS 2. STM has lock on all swarms. All are transmitting at high power.
All radars on payload.
ACS
Boom deploy squib.
ACS-2 align.
All pots.
And as we hear the chatter quiet down, we heard we had splash on the first stage. We also had good tracking on the radars. The PI seems happy now. There at the bottom center screen. You see the PM behind him, test director up on the pedestal. Everyone now intently looking at data screens directly in front of them on our video wall in the range control center. And they will collect the data now, head back to the laboratory to make sure they get everything happy. I want to thank you for joining us today for the coverage of our NASA's APEP mission, an acronym for Atmospheric Perturbations around the Eclipse Path. I just had to say that word one more time, perturbations. I practiced all week on that. So we launched 3 rockets today as part of a salvo on all 3 of our launchers from the pad on Wallops Island. Pretty exciting day. I hope you enjoyed the eclipse. We'll leave you with a What's Up at Wallops video here, and we'll see you again. Look, make sure you tune in to our social media pages for updates on everything going on at Wallops. Good day.